Hello everybody, now we're going to have a look at some examples using the work from the unit circle. This is built into two sections. This first one is going to look at the special triangles in particular and some properties of the unit circle. So example 1, use a unit circle diagram to find the values of cosine of minus 270 degrees and sine of minus 270 degrees. Okay, so if we draw the unit circle and we imagine the x-axis as being the cosine theta axis and the sine theta axis, and that's because, of course, any point, the x-coordinate is the cosine of the angle and the y-coordinate is the sine of the angle. Well, if I have minus 260, the minus sign is implying that I'm going in the reverse direction to what we usually see. So we're going to go 270 degrees in that direction. And if I do that, I am going to end up here. So if I am at that point, well, what is that point? Well, it's a unit circle, and cosine is the x-axis, and you can see this point I'm putting a cross through has an x-coordinate of 0. So cosine of minus 270 is going to be equal to 0. If I think about the sine of minus 270, well, that's the y-coordinate of that point of the crossing. And if the unit circle has a radius of 1, then that is going to be 1. In other words, that particular point is 0, 1. So cosine of minus 270 is 0, and sine of minus 270 is 1. Example 2. Find the exact values of sine alpha, cosine alpha, and tangent alpha, for alpha being 3 pi over 4. So first of all, let's draw a picture of the unit circle again to visualize what's going on here. So we've got our cosine theta axes and we've got our sine theta axes. And if we're thinking about 3 pi over 4, well, pi over 2, or half of pi, is going to be 90 degrees, and a full pi is going to be 180. So 3/4 of pi, or 3 pi over 4, is going to be an angle like that, 135 degrees. So 3 pi over 4. So we have the unit circle, and we are there. That 1 represents that hypotenuse length of 1. So what are the x and y coordinates going to be of this particular point? The y coordinate is going to be the sine of the angle, and the the x coordinate is going to be the cosine of the angle. I must admit, I made a slight mistake. I make sure I use the alpha that they've given in the question. So let me just change that slightly. Okay, so this is a unit circle question, because if you've remembered your unit circle from the notes, okay, and we've got these things happening here, we should know that we can sort of put this on top of that unit circle diagram to reveal the answers. So if I know that unit circle and I know that I've got pi over 4 sort of there, then I know how long that opposite is. That's going to be 1 over root 2. And I know that this length here, this adjacent, is going to be 1 over root 2. So I've got this coordinate point here being 1 over root 2, 1 over root 2. And that means that sine of the alpha angle is 1 over root 2. And I know that cosine alpha is also 1 over root 2. And what about tan? Well, tan, if you remember, tan of an angle is the sine of that same angle divided by cosine of that angle. So we're going to use that to help us. So we're going to do 1 over root 2 divided by 1 over root 2. So, of course, the answer is going to be 1. Now, have I made any mistakes? I've made a slight mistake here. What have I done wrong? Can anyone spot it? The original coordinate here is actually going to be negative, isn't it? That's a negative x coordinate. So I'm going to write a minus 1 over root 2 there. So just double check everything. So just correct myself. Cosine is minus 1 over root 2. So when I'm doing this in, actually, my tan should be minus 1. Sorry about that. Okay, but keep checking your work and you will get the right answers. Right, the next one. Find the exact values of sine of 4 pi over 3, cosine 4 pi over 3, and tan of 4 pi over 3. Okay, so again, we're going to use the same strategy let's draw out the unit circle and let's think about our cosine axes and our sine axes again. And so if I think about this, well, 3 pi over 3 is going to be 180 degrees, and another pi over 3, which is like a bit like 60 degrees, is going to bring us into a situation like this. So there we go. That's going to be our 4 pi over 3. So what I'm thinking, if we've got the radius there of 1, what is going to be the length of that triangle? Or in other words, what is the coordinate point of that particular point there going to be? Okay, again, you should be remembering the unit circle, and what we drew last time was something like this. We had pi over 3 and pi over 6. We have 1, we have a half, and we have root 3 over 2. So we can just swap these out. You can see the longer length on that dotted line there is root 3 over 2, which means that is going to be a half. So that tells us that the sine of 4 pi over 3, well, sine is the y coordinate, so it's going to be negative root 3 over 2. This time I remembered the negative sign. And then cosine of 4 pi over 3 is going to be negative a half. It's the x coordinate, look, and there we go. We can see it's across there as a half, but it's the coordinate point I need, so that's why it's minus. In terms of tan, well, tan of 4 pi over 3 is going to be the sine, which is minus root 3 over 2, divided by the cosine, which is minus 1 over 2. So that is going to be a positive number because the negatives are going to cancel out. It is going to be just a root 3. You'll flip over the second number, cancel the 2's, negatives cancel out, and we'll end up with root 3. Right. Example 3. Without using a calculator, show that 8 sine pi over 3 cosine 5 pi over 6 is equal to minus 6. Okay, so there's lots of components to this. Let's start by focusing in on the sine of pi over 3. Again, we're going to draw ourselves a quick unit circle diagram. And so the angle pi over 3 is 60 degrees, so it is going to look something like that. And we should know by now that if we think of these as lengths, we've got a half and we've got root 3 over 2 here. So the sine is the y coordinate, that's the height, which is going to, so sine of pi over 3 is going to be root 3 over 2. Now, in terms of cosine 5 pi over 6 now, let's draw a picture of that one. So same principle, cosine theta and sine theta axes. We've got 5 pi over 6, so we've got to think what that's going to look like. Well, pi over 6 is 30 degrees, so 5 pi over 6 and that 30 degrees are going to make up the full pi, or 180. We're going to look something like this, and there is our number. So that triangle there, look, with those dotted lines, again, we've got the 30 degree smaller angle here, so that means the longer length is going to be root 3 over 2 there, and a half there. So this time we're looking for the cosine of the angle. Well, that will be, so cosine of 5 pi over 6. Well, it's definitely negative because we have a negative coordinate point. We're in that second quadrant, and that will be negative root 3 over 2 this time. So putting this all together, we're going to have that 8 sine pi over 3 cosine 5 pi over 6 is the same thing as 8 times, well, sine pi over 3 was root 3 over 2. Cosine 5 pi over 6 was minus root 3 over 2. So if we work out what that is, well, we're going to have, well, let's keep the 8 there. The denominators are going to be 2 times 2, which is 4. So we'll have a 4 on a denominator. Then we're going to have certainly a negative number because we've got a minus times a minus, and root 3 times root 3 is 3. Okay, so if we carry on doing this, well, 8 times a quarter is 2. So we've got 2 times minus 3, which is, of course, exactly what we were hoping to find. We have shown are working successfully. Okay, so hopefully you followed that. Do have a go at exercise 7D on page 189. questions 1, 2, 5, and 6. There are a lot of questions here. I'm going to go through all of the work solutions in the next lesson for you, but do take a bit of time over this and try and get as much done as you can. Reinforcing these and keep making these become very natural is really important to save ourselves some time later on. So it's a good investment of your time. Good luck.